need to use AC supply, we use what is called as a function generator. Now this is a function generator and you have so many frequencies. This is a variable frequency. So you can switch it on. There are options for a square wave, a sine wave and a triangular wave. And this is the positive and the negative. You have an amplitude knob which can be varied. DC offset is normally kept off. So suppose you connect it to in your circuit and you want to adjust the frequency. These are all frequency multipliers. So you can see now here I have 1. So it is 1 into 1 hertz. I can vary 1, 2, 3, 4 up to 10. Up to 10 hertz. If I press the first one, these are all multiplied by 1. Now suppose I want higher values. Go to into 10. Now it is 1 into 10, then 2 into 10, 20, 30, 40 up to 100. Still higher. Go in the multiplier into 100. So 100, 200 up to 1000. Still higher if I want, I go into 1K. That is 1K is 1 kilohertz, which is 1000 hertz. So now I have 1K, 2K, 3K up to 10K. Still higher it is into 10K. Now I have 10K, 20K, 30K and so on. And finally the largest one is into 100K. So from 100K to 1000K. So you can see that all these values vary from 1 hertz to you have 1000 kilohertz. Any of these frequencies can be used. These are all multipliers. So depending upon your experiment, whatever frequency you want, you can keep it pressed. If you need a sine wave, see that sine wave is pressed. DC offset, you leave it off. Amplitude, depending upon your requirement, you can adjust it. Now next instrument is the cathode ray oscilloscope. Most of you get scared on seeing this. CRT is the heart of it. This is your fluorescent screen. So a beam of cathode rays come and impinge on that. You will be able to see the waveforms. So as soon as you see it, you see that it is switched on. Now you have two terminals here. These are connected to, these are called as the Y plates or the vertical plates. Short the two terminals together. You can see a horizontal line. Now this you can adjust the intensity, focusing, astigmatism, all that till you get a sharp, clear line. Now if I hold only this, there is a lot of disturbance, and if I touch only this, there is no disturbance. The one that doesn't give you disturbance is the negative terminal, and this is the positive terminal. Now here there is a position knob. If I move it, it moves from left to right, and here it moves from top to bottom. So keep it at the center. This is like your graph paper. You have the y-axis here and the x-axis here. It is divided into graduations. Now you can see different waveforms, and you know an AC waveform can be represented in the form of a sine wave. I am just going to connect this positive to the positive of this frequency generator. This is connected to the negative, and I am able to see a sine wave. And for this, you know, a sine wave, voltage is plotted on the y-axis, time on the x-axis. So whenever you want to measure the peak to peak voltage, you have to measure the distance from the top peak to the bottom peak. So you can see now what is the frequency generator doing. If I keep a square wave pressed, it gives you a square wave. If I press the sine wave, it is showing you the sine wave. A triangular wave is shown like that. If I change the frequency here, the frequency there changes. If I turn the amplitude here, the amplitude changes. So all that can be controlled by the function generator. Now let us assume that I have chosen a sine wave which is within the screen. I can go as much as this, not more, so that I can read the readings. I want to find the peak to peak voltage. Now check out how many divisions are there from the top peak to the bottom peak. So keep it on the y-axis. So this is 1 square, that is 1 division, and each division is again divided into 5 equal parts, 0.2, 0.4, 0.6, 0.8 and 1. So the number of divisions from the top peak, 1, 2, 3, 4, 5, 6, and then the next line, that is 6.2 divisions are there from the top peak to the bottom peak, multiplied by, this is called as voltage sensitivity, that is volts per division. It is kept at 0.5. 0.5 volts per division is the voltage sensitivity, and there are 1, 2, 3, 4, 5, 6.2 divisions. So the total voltage will be the number of divisions multiplied by the voltage sensitivity. In this case, 6.2 multiplied by 0.5. That will give you the peak to peak voltage. If you want the peak voltage, you have to divide it by 2, and if you want the root mean square voltage, that will be Vp by root 2. So this is how you measure the voltage on the CRO. Next you need the frequency. Frequency is reciprocal of time. So, and you know time is always plotted on the x-axis. So the number of divisions on the x-axis between the positive one peak and the next peak from here to here, that will be called as the time period. So now let us see how many divisions are there from this peak on the x-axis. One division, exactly 2 divisions. Now this is the time base or time per division. It is kept at 1 millisecond. And you have to see the multiplier. Multiplier is into 1. So 2 divisions into 1 millisecond into 1. If you multiply all these 3, you will get your answer in milliseconds. So 2 into 1 into 1, that is 2 milliseconds. That is 2 into 10 power of minus 3 seconds is the time period of this sine wave. Then what will be the frequency? Frequency will be 1 by time period, that is reciprocal. So till now we were using only the Y plates of the CRO. That's why these two were in the internal mode. These two knobs are in the internal mode. Now if you have to measure, see Lisajo's figures or measure the phase, then you have to use the X input. For the X input, whenever you connect, you have to put these two to the external mode. Okay, so that is a different experiment. So this is how you read frequency and time period of the sine wave using the CRO.